All right, starting chapter 4. It's a very short chapter, too. 3 sections long.
Yeah, I'm not ready.
And we're not going to be spending 4 days in one section like we did in the last chapter. 4-1, day 1. We are going to look at, like I said, the graphs of the 6 trig functions. And all of the trig functions fall in a family of periodic functions. Periodic functions are functions that repeat their values over and over. Where did I put that dumb clock at? Here it is. Okay, so everybody made the graph just fine. What you did was you measured the distance from the end of the hand to the bottom of the paper, and you went to the 2, the 1. Some of you got clever and said, ooh, the 11 and the 1 are going to be the same distance away. And how many caught that? And didn't have to measure again. The 10 and the 2 were the same, and the 9, and you went around. If I had you go around again and extend your graph out for another full rotation, what would you see? Because right now you had this. You went like, and you had this kind of graph. What's going to happen if I made you go around again and measure the distance back to the bottom? You're going to get another one, the same thing. What if I had you go around 3 times? You're going to get those same, it's going to keep going. So the more you spin, the longer the graph gets, but it's chunks. These chunks are identical to each other. That's called a periodic function, where you know you get the same set of values every time. So understand what periodic means? Okay, we're going to look at sine and cosine today. So we're going to look at the regular pattern for sine and cosine, and then we're going to start changing things a little bit. So the first graph we're going to look at is the sine function. So grab your calculators. Put yourself in radian mode. Radian.
Is it just automatically radian?
Yep, we're going to do all radians. Okay, go to y equals. Clear out anything that's there. And we want to graph the sine function, sine x. Sine x. And then we're going to go to the window, and what's nice is, not window, zoom. Go to zoom. Press your zoom key after you get y equals sine x in. And there's a nice zoom trig, and it sets up a nice window for us. So type in y equals sine x, go to zoom, press the 7. Okay, if I was to cover up this side of my graph, does that look familiar to you? What does it look like?
Our graph.
It looks like your graph you graphed on Friday. That was a sine function that you graphed. I mean, this one's going right through the x-axis. Yours is up a little bit, and we'll be doing that tomorrow. We'll shift it up, and we're going to be able to write the equation for that graph that you have tomorrow. But for today, the basic sine graph starts at the origin. You can see it comes up to a max, then starts coming back down, crosses the axis, down to a min, and comes back up. What we're seeing is 2 cycles of the sine. You guys paying attention? It's all important here. Okay, I want you to press the window key to see what window this thing got set up as.
When I hit zoom in, it didn't zoom at all.
I didn't say zoom in, I said zoom trig. Okay, negative 6.15. If you were thinking in terms of pi, what do you think that is close to? Negative 2 pi. 6.15 is about positive 2 pi. 1.57, how much of a pi is that? Half. So they put a tick mark every half pi. But the window is going from negative 2 pi to positive 2 pi. So if I go back to the graph, this is at negative 2 pi. 0, this is at positive 2 pi. It's just the standard window that the programmers made here. So what we want to do is look at this regular pattern for sine. So, we're going to make a little table. X, Y. There's going to be 5 key values, 1, 2, 3, for every trig graph. And they're all evenly spaced. So the x value we're going to start out with is an x value of 0, and then we're going to finish at 2 pi. So our first value is at 0. Our last value is at 2 pi. And if these are all evenly spaced, these key values, what's going to be in the middle here? 1 pi?
Does it matter if my calculator put in a different number for that?
Did you do zoom trig?
Yeah, I did negative 8.639.
Oh, try it again. Zoom.
Yeah, I did it twice.
Oh, you did. Yours is doing it different then. So yours doesn't look quite like mine.
Well, it looks the same, but it...
Your axis must be going back just a little bit farther is all.
Okay. So, but it's not going to...
Nope, nope, won't change a thing. Okay? This is what you're going to be doing for homework, is making these tables. So if you know where it starts and where it ends, how did we get this middle value? Just cut it in half or average those together. What's halfway between 0 and 1 pi? Half pi, pi over 2. And what's halfway between 1 and 2?
3 pi over 4.
What's halfway between 1 and 2?
1.5.
1.5. Let's use a fraction. We're just adding and dividing by 2. So what's 1 plus 2?
3 over 2.
3. Divide by 2. 3 pi over 2. Okay, now we want the y values. What is the sine of 0? So go ahead and get out of this screen. Quit this. Sine of 0. Oh, we might be able to just get these off our sheet too. Sine of 0 is?
0.
That's why we're starting at the origin. Sine of pi over 2.
1.
Is 1. Sine of pi? 0. Sine of 3 pi over 2? Negative 1 and 2 pi. Back to 0. So, we do rough sketches. We're going to graph this one cycle of sine. So if I want all of these evenly spaced, what's each tick mark going to count? If I want a tick mark for each one of these, how far apart are these? Half pi. So this is going to be pi over 2. 1 pi. 3 pi over 2. And 2 pi. And the highest value that sine takes on this equation is 1. The lowest is negative 1. And now let's just plot the points. The origin is the first point. Pi over 2 is up at its max. Came back and hit the axis. Bottomed out at negative 1. Came back and hit the axis. So is this a straight line graph? No, it's a nice smooth curve just like you had on the clock graph. And I'm not going to make you put the in-between values. I just want you to know that it's going to be nice and smooth. They're not pointed graphs. So what we want to get in the habit of doing for sine is where the y values are at. So I call this first value an axis value because it's hitting the x-axis. So my first key value in the regular pattern is axis. Then it travels to its max. So axis to max.
Are you writing the axis and the max to be underneath the table?
Yep, axis is here with the 0, because that's the first y value here is on the axis. Then the y value is at a max. Where does it go to next? Back to the axis. Then a minimum. And then axis. So it's axis max, axis min, back to the axis. You're going to want to memorize that pattern. It'll make your life easier. Okay, now we're going to change, I want to do cosine. Y equals cosine x. Let's take a look at the graph. Cosine x. And again, with that same window, if I just hit graph, it's going to give me 2 cycles of cosine.
Wow, mine looks different.
Okay, I want to change it so we only see 1 cycle. Go to the window. Go to the window. I want you to change the x min to 0 and the x max to 2 pi. So that we only see the 1 cycle of it, so it's a little bit, and leave everything else the same. Just graph. So I'm going 0 to 2 pi, everything else is going to stay the same. They're going to give me a tick mark at every pi over half pi, and it's going up to 4 and down to negative 4. Graph. There's 1 cycle of cosine. I think of it as the cereal bowl. Sine is the snake, cosine's the cereal bowl. See how that's a little bit of a bowl shape? Okay, so we're going to make the table and look at the regular pattern. So x and y, 5 key values. Okay, in the regular cycle for cosine, it starts at 0 and finishes itself at 2 pi. It's like 1 rotation around the circle, just like the clock. So then you know you got pi in the middle, pi over 2, 3 pi over 2. So now we want the corresponding y values. So if I quit the graph, what is the cosine of 0? 1.
How do you get your graph to one side?
How did I what?
Get your graph to one side.
Window. 0 to 2 pi. So go ahead and fill in those next 4 values. So what was the second value?
0.
0, and then the pi?
Negative 1.
Negative 1, and the 3 pi over 2?
0.
And the 2 pi?
1.
1. So cosine looks like this. My x's are still the same, pi over 2 apart. And we still have a max of 1 and a min of negative 1.
Will the axis always be the same?
No. We're going to be changing things up here shortly. Because we can. We don't want to keep it that boring. So, cosine starts up here at 1 when x is 0. Then it hits a 0. And it goes down to negative 1. Back here. And then back here. Nice smooth curve. And if I was to continue this to show the arrow that it does continue on, it would be going down this way, and it would be coming down this way. Okay, our pattern for cosine in terms of y's, where does cosine start? If I consider this my first value, what are we going to call that?
Max.
That is a max. So cosine starts at its max, then where does it go?
Axis.
Hits the axis,
And then minimum.
then a min, very good, then an axis, and then a max. This is the pattern you're going to want to memorize. Max, ax, min, ax, max. Okay, now we're going to start changing things. A little discovery with the calculator, and then we're going to make some graphs. Can I get rid of this? Okay.
I know.
Let's see, over here. So a little explore. Nope, not, no, actually. We're just going to make some graphs on the calculator, but we're not going to write them down. We are going to put a multiplier in front of the function. So we're going to call that multiplier an a value. Okay, are you ready? With your calculators in hand. Go back to y equals. I want this to go back to sine x. And I want to change the way it looks. Did you ever have it in? I want you to use your arrow to the left and go all the way back to this diagonal line here. Can you go all the way back to that diagonal line. Oops. And then hit enter once. What it does is it makes the line very fat. So if we graphed it now, there's sine, but the graph is much fatter than it was before. It's going to help us distinguish between the new ones that are coming up.
Why doesn't mine graph?
It didn't graph?
No, I got the sign, the X, the fat line, but when I press graph, it's like graph.
Do you have this? Does the equal sign have a highlight on it?
Nope.
It needs to be hit enter on that.
Number Gucci.
Alyssa, did you?
Yeah, mine's different. It gives me a bunch of different options.
Yeah, you can scroll through a bunch of different options. I just wanted the one that was fat. You can do a dotted line. You can do a running little thing.
Yeah.
I just want the fat one. Just keep hitting enter and it'll go through all of them.
Yeah, I got it, but it's not graphing.
Or go back and hit on your equal sign. Hit enter on that. It's probably turned it off somehow. It needs to be highlighted. The equal sign needs to be highlighted for it to graph. Are we good? Otherwise, bring it up here.
It just doesn't look any bigger. I don't know.
Let me see. No, it doesn't look good. Let's see. Y equals. Oh, maybe you just get to pick colors. Maybe that's what it makes. Yeah, just pick a color for it.
Okay.
Yeah, you fancy pants. You're fancy pants. Colors. Yeah, it probably doesn't because you can pick a different color for each one. So just pick a different color for each one. Okay, let's put a multiplier in front of that. Let's try 2. 2 times sine x. And just keep it regular. So this will be the thin one for us. So what does multiplying by a 2 do to the graph?
It makes the dips bigger.
Makes the dips bigger. So our max is getting maxier and our min's getting minier.
Yeah.
Wait, did that say 2 sine x?
Yep, 2 times the sine of x. How high do you think that max is at?
2.
Looks like it's at 2 and the min's at negative 2.
Yep.
Let's go back. Put in 4 sine x.
Where you crazy?
What should happen here?
I bet whenever the number before you should go even bigger.
It's double.
Should get higher.
Oh,
Oh.
whatever number you put at the beginning of it is how high your
Mhm.
max is and how low your minimum.
Very good. What if I put in a half?
Why you gotta do me like that?
0.5
Whoa, I made it
Sine.
slimy.
x. What's going to happen here?
Freaking sweet. It's slimy.
Oh, it's liney. You shaded. Let's not lose focus here.
Yeah, Kelly.
Let's not lose focus, Kenley. So the half only made it go to a half and down to negative a half?
Yep.
That's an easy concept to see. What kind of numbers haven't I tried?
Like the ugly one.
20, so it's going to go up to 20 and down.
Who knew?
Fractions.
I just did a fraction, I did 0.5. Get rid of your 2, 3, and 4. Clear, clear, clear. How about a negative multiplier?
Hey, Mr. Schwartz, we're
Mine
gonna
is
try the
12
negative
because
one
it's in
yet.
colors.
Oh. How about a negative 2
You can't do anything until it's after it's done graphing.
sine x? Try a negative multiplier. Not a subtract, but a negative.
It doesn't graph.
It should graph.
It is graphing right now. It's just taking a while. It's just
Oh, is it?
It's
invert.
opposite.
Oh,
invert.
there's the normal one.
Infinite.
So it flipped it over and it made it go to 2 and negative. Do you see it flip? Instead of going up to its max first, it's going down to its min. Okay, so we learned a lot there, didn't we?
It looks like DNA.
Okay, looks like DNA. So, if I had put a cosine in here, same things would happen just with the cosine graph. The max would go up, the min would go down, it would flip it over. So it doesn't matter whether I put sine or cosine. Tell me the 2 things that A did for us.
It made it bigger, small.
Made what big or small?
The line.
The max and min.
Changed the max and min. It changed
Why is there cosine above that?
the max
They're interchangeable.
and min.
Just to confuse you.
So it increases the max and min or decreases it. And what else did it do?
It inverted
It, what do we call that?
a flip.
Reflection. It reflected it.
Yeah.
And it reflected, flipped the graph
Why can't you focus?
if A
Ouch.
was, I guess I could, negative. Okay, what that A number is referred to as, the reason we use the A is it refers to the amplitude of the graph. So the amplitude, A is amplitude, and that amplitude is defined as the distance between the axis and a max or the axis and a min distance. So it's the distance between the axis and a max. The distance between the axis and a max. So I want to go back to our first graph. I know they are kind of long.
Can't go back to the first graph yet.
Why not?
Because we're not done.
All right, amplitude, the distance between the axis and a max. I'm going to quit soon here.
Between the axis.
And a max. Or the axis and a min. So, now can I go back to the first graph? And add to that picture.
It's up to Lexi.
Yeah. Are you done, Lex? I mean, I guess.
Okay, come back here. So on this first graph, this distance in here, here's a max, here's my axis. What's that distance? That's a distance of 1. What's my number that's sitting in front of sine here that we never write down? 1. So this right here, this distance of 1 is my amp.
Why would you just call it A?
I know it's one A.
A. That's my amplitude. Amplitude is always a positive value because amplitude is defined as distance. But is A always positive? No, A can be negative, but amplitude is a distance. So maybe I should not call that A. I'm not going to call it because it's technically not. This is A right here. A is the 1 that's sitting there. But this is the amplitude is the distance. Okay. Same thing on the cosine. It's the distance between the max and the, I'll go with this one here because you can see it better. Max and the axis. What's that distance equal to on this graph? 1. Where does that show up in my equation? Right here. The 1. There's my amp. Okay. So let's try a couple. How I want to. Boy, we're not going to get nearly as far as I wanted to get today. Make a 2-period table. 4.
These are long notes.
They are.
I mean, Mrs.
Yep. I'm only like halfway through. I'm not going to get as far as I wanted to get, but that's okay. We will adjust tomorrow. Okay.
What are you talking about? Stop trying to condense my life.
Okay, make a 2-period table for y equals 2 sine x. So without a calculator, because all of this stuff is going to have to be done without a calculator come test time.
What?
So you're not going to be using the calculator to do these.
Why not?
So we're going to do one table at a time. Yes, that's my plan.
Ouch.
Okay, the x's have not changed for us yet. What's the first x value that we start the graph for sine at? First x value is?
0.
0, and the last is at?
2 pi.
2 pi, and you know the ones in the middle here. Pi,
You're getting 2 sine over trig.
pi over 2, 3 pi over 2.
This is a bunch of weird
Okay.
talk.
What was our pattern for sine? In words, what was the pattern for the y values? Snake. Where does the snake start?
0.
On the axis. I want words first. Then it went max, back to the axis,
A slithery little snake.
min, axis. Okay, what's my amplitude on this graph?
2.
How do you know it's 2? Yes.
At birth.
Pay attention. Amp is 2. Where are my axis values at? What's the y value if I'm crossing the x-axis?
Where's your y? 0.
What's my y value if I'm crossing the x-axis? How high am I above the x-axis?
0.
0. My axis values are 0. 0, 0, 0. Right here. I'm on the axis. What's my y value right here at the origin? What's my y value here? What's my y value here? Okay. Max, because I have an amplitude of 2, how high did this graph reach? To 2. The min? There you go. I wanted a 2-period table. So we now have the option to continue to go. So it would be this graph, except it would be higher. I can go from here out, or I can go from the 0 back. The book goes from the 0 back, if we want to match what's in the book. It doesn't matter.
Why would you go into the negative?
I don't know, because we can. So let's go into the negatives.
Okay, why do you keep writing amp instead of A? I'm confused.
Because
they're not
A
the
equals
same
amp.
thing.
They're not quite the same thing. When we get to a negative, you'll see. Okay, so if I'm at 0, I'm going to continue because I'm going to start at the same origin value. The two graphs are going to share this point. But where is this one going to finish if I go backwards?
Negative 2 pi.
Negative 2 pi. Do you agree with that?
Yeah.
If I went from 0 and I go back a full cycle, I'm going to be back at negative 2 pi.
Yeah.
So my end value is negative 2 pi. What's my middle value going to be?
Negative pi.
Negative pi.
Is there such thing as more than a 2-period table?
Oh, I could make you do 10 if you wanted, but we're not going to.
How does that work, though, after...
Well, where would the next one go? From negative 2 pi
Negative 4 pi.
to negative 4 pi? If we wanted to keep going left.
Negative 4 pi, and then it would be negative 6 pi.
Yeah.
Could your table go positive or negative?
Yes.
Yes, it could go. At this point, when I say make a 2, it doesn't matter whether I go from 2 pi to 4 pi now or go backwards. Okay, what's this one?
Negative pi over
2, and then,
negative 3 pi over 2.
okay, be careful here. Think of, let's see.
I thought we were going the other way, because
I am.
the smallest from,
I'm going from here backwards. Okay? So let's even start the sketch a little bit right here. It will be. Nice vision. You have to have vision when you do these. You can't just automatically. 1, 2, yep. I'm going to fill in the table here in a minute.
is this the, okay, never mind.
There's negative 2 pi. And my max and mins, I've got to go up to 2. And down to negative 2. So we just did the first one. 0. Okay, you ready for the other?
No, no, no.
Not yet?
Wait.
Is everybody okay with what I did here with graphing this first cycle of sine? Two sine.
Yes.
Okay. The two graphs are going to share this origin point. So my second table, I'm sharing the origin. So I've got an axis value. But think about sine here. Is it going to go up to its max from here? It is not. Where's it going to go? Down to the min. So my next value in my table would be the negative 2. And then where's it go? Back to the axis. Then positive 2. And back to 0. So the axis values match. Just that your min and max will flip because of just the way the shape of sine works. Are you okay with that? And I want to do one more with the cosine and a negative. I'm going to call it good for the day. And I got half of what I thought we could get done today. Directly half. Okay, so number 2. Y equals, let's go, negative 3/2 cosine x. So what's my amp here on this graph? The amp is the distance. That's 3/2. It's 1.5. But what is this negative going to do to my graph? It's going to flip it. I'm going to write myself a little note to flip the graph.
Is that like the same amp as in like when you like play guitar?
Sure.
Absolutely.
Why is second day she's been hanging out with kids?
It's her birthday yesterday. Awesome.
Oh, happy birthday, Zoe. Take over here.
Nice try. Nice try, Kenley. Okay, let's see. Okay, graph. X. Y.
Oh, amp is neither negative.
Amp is never negative. It's a distance.
Yeah, but I didn't comprehend it. until I
No.
saw it.
But we do know that that negative will flip our graph over, but the amplitude, that distance, doesn't change because it's flipped over. It's still going to be 1.5. So when you mark amplitude negative on the test, what happens? -1 for you.
Minus 1 for you.
Wait, what did you just say?
If you were paying attention, you would know.
Does my voice not reach you the first time I say something?
No, I heard it, I just didn't comprehend it.
All right. What about the x's? What do we got here? 0
It's the same thing, but they're all
What am I
negative.
to 2 pi,
Oh, yeah.
pi,
A can be negative.
pi over 2,
Yeah,
3 pi over 2. X's are not a problem.
Aren't they negative though?
X's aren't negative. No, it's still going out to the right on the x-axis. See, I'm still going to have this going on, but the thing's going to flip over. I'm still looking at this part of the x-axis.
The x's will never be negative.
Well, if we do the second table, they're going to be.
Start right now.
Okay, so cosine's normal pattern is what? Normally it's max, axis, min, axis, max. That's its normal pattern. But if this thing reflects, what happens? What changes when it reflects?
You start with minimum.
Yes. Do the axis values change?
No.
No. Just that maxes are going to come down and be mins, and the mins are going to go up and be a max. So
But the axis will stay the same.
the axis is going to stay the same. So instead of a max, we're going to have a min, then a max, then a min. Where is my minimum going to be at?
Negative 3 halves.
-3/2. Where's my axis at? 0. My max?
Can I go do something really quick?
Yep, really quick.
Something shut the door.
All right, second table.
At least it would be nice when Gus just let her rip in here.
We're entering 2 for this.
2 for this one, yep. But for the first few days, we're going to be making 2. Okay, so what are my x values now if I'm going to go backwards from the origin, 1 full length? So it'd start at 0 still and finish at -2 pi. We're going to change the x's tomorrow. Pi over 2, 3 pi over 2.
Wait, aren't they negative?
Oh, yeah, I just said it.
I know.
Okay, let's look at the graph before we do the y's. Sometimes I think it's easier to make the sketch.
I think we're trying to replace
Okay.
I just 100% bombed.
Bombed it? That's not good. Okay, you ready? So graphing our first one, we said it was going to be down from 0, it's going to be at -1.5. Then it was going to hit,
Why are we doing 2? I thought it was 3 over 2.
that's 1.5. I went halfway between my 1 and my 2.
Oh, okay.
Okay. Then I'm at the axis. Then I'm at 1.5, so I'm going halfway between my 1 and 2. Axis. Nice smooth curve. So all I did was plot the 5 points in the first table. Nothing too tricky there. Are we good? Not yet. Okay, my second table. I'm starting at this point. So my 0 is -3/2. Where's cosine going to go from here? It's got to go back to the axis, which is 0. Then where's it going?
3 halves.
Up here to its max. Then back to the axis, finishing out at minimum. So what happened with the y values this time? How How do your y values compare to the table above? This is big. Pay attention. Right here. They came out exactly the same. Why did they come out exactly the same?
The thing was negative.
Nope, it'll happen no matter if it's positive too. If you take a look at this, cosine is, it's called a, it's a symmetrical. If I fold this on the y-axis, will those two overlap?
Yeah.
Yes, they do. So it has that line of symmetry at the y-axis where sine did not. If I fold it on the y-axis, sine does not match. So the cosines, the y values will always match because it has that vertical line of symmetry. Sine doesn't have a vertical line of symmetry. Are you okay with that? So cosine, your y's will always match. Okay, I've got a worksheet for you, but you cannot do all of it. So I'll tell you how many problems you can do on it.
Why don't we just save it till tomorrow and then we just do the whole thing tomorrow?
Oh no, we don't want to do that.
Gotta find a way to attach a link.